Bismillahirrahmanirrahim. Welcome to lecture number 19 of the course Introduction to Computer and Programming. In this lecture, first of all, I will show you a program in which we will see some pointer arithmetic, and we try to understand some concepts of pointer arithmetic. And then I will give you introduction of the sorting techniques. Sorting means that we are going to sort the value of the elements in the array. Array में जो भी elements हैं उनको sort करने के लिए there are some sorting techniques. For example, आप ascending में sort करना चाहते हैं या descending में sort करना चाहते हैं. And then we comes to passing an entire array to a function. In the previous lecture we have seen that how we can pass individual element of an array to a function by value and by address. And now today we see how we can pass an entire array to a function. Then some pointers and array concepts, where we discuss that basically array is a pointer to a group of element having same data type. Then I will give the introduction of 2D array, two-dimensional array को देखेंगे, and we will write a simple program जिसमें हम 2D array में यूजर से values input लेंगे और उसमें कुछ manipulation करेंगे. Let's see the outline of our previous lecture. What we have covered in our previous lecture, we have seen a program to calculate a percentage marks, and then we have seen how we can initialize an 1D array, bound checking of an array. Bound checking means that you are not going to access the element of the array that doesn't belongs to that array actually, कि array का जो size है उससे बाहर जाके element को access ना किया जाए. Then passing array element to a function by value and by address, individual element to a function, and today we will see how we can pass entire array to a function. And then some pointer arithmetic, then printing value of array element using pointer. So in this we have also seen a function जिसमें we will call the function and we pass the base address of that array to that function, and in that called function we have a pointer. That pointer points to the first element of that array, then we print that value and increment that pointer. So that is very important concept. Today's lecture outline, today's we see some pointer arithmetic in a program, and then so we sorting techniques, and then I will show you one program of one of the technique, and I hope that you will be able to write the program for other techniques as well. Then passing an entire array to a function, arrays and pointer. So that is very important concept, and in this section we will see that array is actually a pointer that points to a group of element having same data type. Then two-dimensional array. Until now we have seen one-dimensional array that has only a single row. Now in two-dimensional array we have rows and we have columns. Let's come to the pointer arithmetic program. So this is a program that use some basics of the pointer arithmetic. The first three statements are the declaration statement, where we are declaring and initializing some of the variables. The first statement is we are declaring an integer variable I and an integer type pointer x. Second statement, we are declaring a variable j float type and assigning a value to it 1.5 and a float type pointer static y. And in a third statement we are declaring a character variable k, assigning it a character constant c, and declaring a character pointer static z. So pointers, regardless of the type of the pointer always take 4 bytes in memory. Okay? So the type means that the memory they are pointing to store the integer type value if the pointer is integer type, and the memory the pointer is pointing to store floating type value if the pointer is float type, and similarly for the character. So when these three statements are executed, memory will be allocated to these 6 variables. 3 of them are ordinary variables and 3 of them are pointers. So like this. And then the next three statements. So as I told you before, that for integer variable, if we are declaring an integer variable, let's say in this program we have integer variable I, then 4 bytes of the memory will be allocated to that variable. As you can see that these are the 4 bytes that will be allocated, and 560 is the address of the first byte. जो फर्स्ट बाइट है इन 4 बाइट्स में से 560 उस बाइट का एड्रेस है. नेक्स्ट बाइट का एड्रेस क्या है? 561, 562 एंड 563. सो दीज 4 बाइट्स कंस्टिट्यूट अ मेमोरी फॉर अ इंटीजर वेरिएबल. ठीक है. देन वी हैव 3 printf स्टेटमेंट्स. इसमें i, j और k की वैल्यू प्रिंट हो जाएगी. सो द वैल्यू ऑफ i इज 3, वैल्यू ऑफ j इज 1.5 and value of k is c. So these 3 values will be printed on the screen. Now the next 3 statements are the statement where you are initializing the pointer value, the value contained by the pointer, that is a memory address. So in the first statement you are assigning the address of the memory that is allocated for the variable I, and you can access that address using AND operator. So AND means address of I. You can read it address of I. You can read it like address of I, and you are assigning that address to X, not static X, to X. So that will be stored over here in this place. So when this statement is executed, so 560 address is assigned to a pointer X. Now that pointer points to a memory location that is allocated for the variable I and whose address is 560. The next statement is y is equal to AND j. AND j is address of j. So address of j is 790, and here we are assigning that address to a pointer variable y. So the y contains the value 790, and that is, it is pointing to a memory location that is associated with the variable j. In the next statement we are initializing a third pointer with the memory, with the address of the memory that is associated with the variable k, and that memory address is 320. So 320 address will be assigned to z, and now z pointer points to the memory that is allocated or associated with the variable k. Now the next 3 statements are the printf statements. So the original address in X is equal to, so X की value क्या है? Static X is different. Static X means you are dereferencing a pointer, and that means that you are accessing the value that is placed at the address that is held by that pointer. So ये pointer जो है X pointer, ये कौन सा address hold करके रख रहा है? 560 is the address that is held by the pointer. So static X means the value at 560, and the value at 560 is 3. So static X means 3 and X means 560. So here the original address in X is equal to 560 will be printed, and the original address in Y is equal to 790, and the original address in Z is equal to 320. That will be printed on the screen. So these are the 3 addresses: 560, 790 and 320. These are the addresses. And pointers, for pointers these are the value of the pointer. जिस तरह से हम कहते हैं integer variable I है, इसकी value क्या है? I की value 3 है. So एक pointer variable X है, उसकी value क्या है? उसकी value एक memory address है, and that address is 560. So let's say we have a pointer X. What is the value of pointer X? The value of pointer X is 560, and when we dereference that pointer, that means when we try to access static X, that is value at address 560. So this means that 560 address पर क्या value है? That value is 3. Now the next 3 statements are, so ये जो I, J और K को memory allocate हुई थी, ये मेमोरी स्टैंड अलोन एलोकेट नहीं हुई थी. इसके लेफ्ट, राइट, ऊपर, नीचे भी मेमोरी लोकेशंस हैं, राइट. सो दिस इज व्हाट आई शो. द नेक्स्ट मेमोरी लोकेशन स्टार्ट्स एट एड्रेस 564. व्हाई? बिकॉज 561, 560, 61, 62, 63, these are the 4 bytes. ठीक है. 560 is the address of first byte, 61 is the address of second byte, 62 is the address of third byte, and 561 is the address of first byte, 560 is the address of first byte, 561 is the address of second byte, 562 is the address of third byte, and 563 is the address of fourth byte of this whole memory जो dark blue में आपको नजर आ रही है, right? And then the next address starts at 564. Same is the case here with the floating point variable, because a floating point variable also takes 4 byte in memory, but in case of character variables the next address starts at 321. Why? Because the character variable only occupies 1 byte in memory, so it occupies 1 byte, so that is the address of 1 byte 320. The next memory address starts from 321, right? Now the next 3 statements are the pointer arithmetic, that is you are incrementing some value, you are adding some constant value in the pointer, and x plus plus means that you are adding 1, that is x is equal to x plus 1. So when this statement is executed, now you will see over here the value of x will be incremented. Now before incrementing that value, do you remember that I told you in the previous lecture that when you increment the value of the pointer, you have to look at the type of the pointer. If the pointer is of integer type, it should point to the next integer value, not the next byte. So the next integer value is 4 byte away from the current position, right? So if the current position is 560, the next integer value lies at 564, right? Similarly, so when that statement x plus statement is executed, the value of the pointer x will be changed, and this will become 564, and it points to the next 4 byte, right? Now when y plus plus is executed, the value of this pointer is also changed. It won't become 791, it won't become 792, it becomes 794. Why? Because whenever you increment the value of the pointer, this means that it points to the next value in the memory location, and the next value is 4 byte away, because the type of the pointer is float. So the next value is 794, and it points to this memory location. So when you execute this next statement, that is z plus plus, then what happened over here? Will it become 324? No, because the type of the pointer, type of the z pointer is character, and the character occupies only 1 byte. So a character pointer points to a memory location where a character is stored, where a character value is stored, and character value occupies only 1 byte. So when you increment that z pointer, it means it should point to the next character value. So the next character value will be at the next byte. So its value becomes 321, that is the address of the next byte, and it points to that memory location, right? So when you execute these 3 printf statement, now the values of new address in x is 564, 4 bytes added from the previous address, 794, 4 bytes added from the previous address, and 321, only 1 byte will be added from the previous address, right? So let's go and see the program. So this is the program. This is the same program that I have shown you, except we have the main function over here and the system pause. Let me include this header file over here. Okay, now let's first compile it and execute it. Now these are the value of the variables. So these are the original addresses, that is the address of I, y, x, y, and z. These are the value of pointer x, y, and pointer z. That is the memory address of I, this is the memory address of j, and this is the memory address of k. Now when you increment it, so यहाँ पर आप देखें the increment of 4 is performed, so 4 byte का increment perform हुआ है, right? This is the original address. Since it's an integer pointer where it points to a memory location where integer value is stored, and integer value takes 4 byte, so the next value will be after that 4 byte. So ये 4 byte का difference यहाँ पर भी आ रहा है, और y की value में भी 4 byte का difference आ रहा है, because y is a floating type pointer, and z की value में only 1 byte का difference आ रहा है. Why? Because z is a character type pointer, right? So you have to remember this thing. Okay, so the things that needs to be remembered are that what is x and what is static x. x is a memory address that is held by the pointer, that is 564, and static x is the value at address 564. So whatever value is over here, that will be written if you use static x. Static x means you are dereferencing a pointer, and whenever I say that dereferencing a pointer, it means that value at the address that is held by the pointer. Now let's see some sorting program. What is sorting? Sorting means arranging element of array in ascending and descending order. So ascending means that the smallest element comes first and the largest element comes at the end, and the descending means the largest elements comes first and the smallest element at the end, and all the in between elements must be arranged. Like for example, this is an array. So this array contains 6 elements, so the size of the array is 6, and its index start from 0 to 5. These are the values written in the red: 24, 34, 12, 44, 56 and 17, and below are the addresses. So 500, 504, 508, 12, 16 and 24. So the type of the array is most probably integer. After arranging array elements in ascending order, so the smallest element should come first and the largest at the end. So this is the array arrangement in ascending order, right? And after arranging array elements in descending order, this is the array arrangement in descending order. The largest element comes first and the smallest elements comes at the end position. So these are the sorting techniques. This is a sorting of an array. So we have different sorting techniques: selection sort, bubble sort and insertion sort. I will tell you or give you introduction of 3 of these sorting techniques, but we will go only in the detail of the selection sort. That will, we will write a program, we will see the program, we will dry run that program. I will tell you how the bubble sort work and how the insertion sort work, but I won't show you the program for bubble sort or insertion sort. This will be your kind of class assignment or home assignment or homework to write the program for the bubble sort and insertion sort, right? So let's see first the selection sort. So selection sort is a sorting technique. You can sort the elements of the array or any list using selection sort in ascending order or descending order. It's how you program. So we are here sorting the elements of the array in ascending order, that is the smallest element comes first and the largest element comes at the end. So it contains some number of iterations. So this is the first iteration. So iteration, if you remember the loop lecture in which we have studied loops, I showed you what is an iteration. Iteration is a one complete circle execution of the loop, right? So this is the first iteration. In the first iteration, this is an array, 0th index, 1 index, 2nd, 3rd and 4th. So 5 elements array में है, 44, 33, 55, 22 and 11. So first you compare 0th index element with the 1th element. So इसमें जो फर्स्ट आइट्रेशन में आप 0th इंडेक्स वाले एलिमेंट को बाकी तमाम एलिमेंट से कंपेयर करेंगे and you will perform swapping. That means you interchange the values if the 0th index value is greater than any of the indexes value, right? For example, in the iteration 1 of the outer loop, I would say, so सबसे पहले you will compare the element at 0th index with the 1th index. So the element in the 1th index is smallest, so you have to swap these values. That means you have to interchange these values. So 33 comes up and 44 comes at the 1th index, right? Then you compare again with 33, that is element at the 0th index. Now it's 33, now not 44, because you perform the swapping, and then you again compare. If the 33 is less than is greater than 55, or we can say 55 is greater than 33. If 55 is greater than 33, condition is false, you won't perform swapping. Then in the next iteration, so we have the outer iteration and inner iteration 1, inner iteration 2, inner iteration 3, inner iteration 4. So this is the inner iteration 3. Inner iteration 3 you compare the 0th index with the 3rd index element. Second के साथ हमने compare कर लिया था. There is no need for the swapping because the element at the or the value at the second index is larger than the value at the smallest index. So what we have to do, we have to take the smallest value at the 0th index. So when we compare it with 22, so 22 is smaller than 33, so we have to perform swapping, and this swapping is performed. 22 comes over here and 33 comes over here, and then 0th index element, that is 22, is compared with 4th index element, and the 4th index element is smaller, then this swapping is performed, that is 11 come at the 0th index and 22 come at the 4th index. Now after this is the execution of first iteration of the outer for loop. इसमें जो सबसे हमारा एक चीज देखें कि जो 0th इंडेक्स पे आइटम है, एलिमेंट है, that is sorted now, that is the smallest element in that array. ठीक है, आप array में जितने मर्जी एलिमेंट्स रख लें, जो मर्जी एलिमेंट्स रख लें, iteration 1 के बाद 0th इंडेक्स पे एलिमेंट अपनी जगह पे होगा. there is no need to compare that element further. So next iteration में the value of I will become 1. So you start comparing one element at index 1 with the element at index 2. If the index 2 element is larger than this element, or we can say that if that element, index 1 element, is larger than the index 2 element, then we have to perform swapping. But index 2 element is smaller than the index 1 element is smaller than the index 2 element, so there is no need to perform swapping over here. So it's the same arrangement as we have in the iteration number 1 of that outer iteration 2, and then we compare the 1th index element with the 3rd index element. Now if the 1th index element is greater than 3rd index element, then the 3rd index element should come up. So we have to swap this value. This is true, this value is larger than this value, so we have to perform swapping, and after performing swapping, 33 comes at the 1th index and 44 comes at the 3rd index. And then in the 3rd sub iteration or the inner iteration, so this is the outer loop iteration 1, 2, and उसमें inner loop 1, 2, 3, 4 दफ़ा execute हुआ, inner loop 1, 2, 3 times execute हुआ. We will see in the dry run, when we dry run that program, we will see how this happens. Okay? Now the index 1 element is compared with the index 4 element, and if the index 1 element is greater than index 4 element, then we have to perform swapping, and that, yes, it is greater than, so 22 comes at that position and 33 comes at the 4th index position, and that will be input to the 3rd iteration. So 3rd iteration में हमारे पास इस तरह की array मिलेगी, where we have to, last iteration में we start comparing with the 1th index element. Now we start comparing with the 2nd index element. So 2nd index element will be compared with the 4th index element, and since this element, 2nd index element, is larger than the 3rd index element, so the swapping will be performed. So these two elements are swapped. Now the 2nd index element is compared with the 4th index element. Now 2nd index element is greater than the 4th index element, so this means that we have to swap. So 33 comes over here and 44 comes over here. So this will be the input to the last iteration, and in the last iteration you compare with 3rd index element with the 4th index element, right? So when you swap these two values, 44 comes over here and 33 comes over here. Now the array become 11, 22, 33, 55 and 44, and in the 4th iteration you compare the 3rd index element with the 4th index element. If it is greater, you swap these two, and after swapping, our array is sorted. So this is the input to the program, to the sorting function or to the sorting program, and this is the output array where the elements are sorted in ascending order such that the smallest elements comes at the 0th index and the largest element comes at the last index of that array. Now let's see the program. Let's see one thing before going to the program, that is, after execution of the first iteration, the element at the 0th index is sorted, that is, it comes at its position. Now there is no need to change its position, and after the iteration number 2 is finished, you see the element at the 1th index, second element comes on its position, and after the execution of third iteration, the element at the third index is organized, and after the execution of fourth iteration, the third index element is organized. And when these 0, 1, 2, 3, these three indexes element are organized, the last element is automatically organized. Organized means that it comes in its position of the ascending order, कि वो ascending order में जिस तरह से उसने जिस position पे आना है उसमें आ जाएगा. Now let's see the C program. So this is a C program where we have the array A, size is 5, so 5 elements of the array as we have seen before, and this is the outer for loop, this is the inner for loop, and in the inner for loop you are comparing basically, and when this value is greater than this value, then you perform swapping. So swapping कैसे perform करेंगे? For example, we have a variable x and we have a variable y, and the value contained by the x is 10 and value contained by the y is 20. Then how we can interchange these two values? Swapping is interchanging the value such that the value of x will become 20 and the value of y will become 10. We can do so. The simplest way is to use another variable. So we have another variable temp, integer variable temp. So what we do is we will write temp is equal to x. We will copy the value of x in temp, then we will copy the value of y in x, and then we will copy the value of temp in y. So इस तरह से values interchange होती हैं, and that is the same process we did for the array elements. So the first statement, when the first statement is executed, so ये जो program है ये main से निकाल के लिया गया. So here we have a main, starting bracket of the main and the closing bracket of the main. ठीक है? So I will show you the program after the dry run. So this is the array we have. Now first the value of I is 0, right? So value of I is 0 and the condition is I 0 less than or equal to 4. The condition is true. So it comes inside the loop. The next statement is again the for loop, where you are initializing j with, so j is equal to I plus 1. That means the value of j is 1. Now you are checking the condition. 1 is less than or equal to 4. Condition is true. So this condition is true. Then you come to the if statement, and in the if statement you are comparing if a of I is 0, if a of 0 is greater than a of 1. So a of 0 is 44 and a of 1 is 33. So I have directly write over here 44 is greater than 33. This comparison will be performed. The condition is true. Now you have to swap. You have to interchange the value of 0th index element and the 1th index element. And how you do this? You use a temporary variable. You assign the 0th index value to their temporary variable, then assign the 1th index value, the value at 1th index to the 0th index, and then you copy the value of temp to the 1th index. So the array will become like this, will look like this. So 33, 44, so these two values are swapped, इनकी values interchange कर दी इन दो elements की, and 55, 22, 11 are same as it is. Then if की bracket close होगी, उसके बाद the loop की bracket close है, it goes up and check the condition, increment the value of j. So when the value of j is incremented, previous value is 1, next value is 2. It again check the condition of the loop, 2 less than or equal to 4. So 2 less than or equal to 4 condition is true. It comes inside, execute this if statement. Now this if statement becomes if a of 0. So value of I is not changed during the execution of the inner loop. ये जो inner loop है हमारे पास, जो जिसका counter j है, इसमें I की value कहीं पर change नहीं हो रही. So a of 0, that is now 33, is greater than a of 2. A of 2 is 55. So if 33 is greater than 55, condition is false. It comes again at the increment decrement part. So it increment the value of I. Now the value of I will become 3. The condition in the inner for loop is 3 less than or equal to 4. The condition is true. So when this condition is true, it comes inside and execute this if statement. Check this if statement. So a of 0, I is still 0, is greater than a of 3. So 33 is greater than 22. So 33 is greater than 22. This comparison is performed in the if statement, and then the condition is true. Then we have to swap the value of 0th index with the 3rd index. So in the value ko swap karna, 22 comes over here and 33 comes over there. So the array will become look like this. So 22, 44, 55 and 33. So these two values are swapped. Now the value of j is incremented. It becomes 4. The condition is 4 less than or equal to 4. Condition is true. So when the condition is true, in the if statement we perform the comparison. A of 0 is greater than A of j, and A of j is A of 4. A of 4 is 11. So 22 is greater than 11. Condition is true. So when the condition is true, the array will look like this. So 11, 44, 55, 33, 22. That is the first iteration of the outer loop, whose counter is I. And in the first iteration, the inner loop, whose counter is j, is executed 1, 2, 3 and 4 times. Then this is the array now. So our original array is changed from this to this, and after the execute now the value of j is incremented. The condition is 5 less than or equal to 4. Condition become false. So the one execution or one iteration of the outer loop is completed, and when the one iteration of the outer loop is completed, you see the first element in the array is sorted, that comes in its position. Now this is the input to the second iteration. So this is the same array. The output of the first iteration, now the value of I is 1. Previously the value of I is 0. Now the value of I is 1. The value of j is I plus 1, that is 1 plus 1 is 2. Now the condition is 2 less than or equal to 4. Condition is true. In the if statement we will be performing the comparison. If A of 1 is 44 is greater than A of j. A of j is 2. So 44 is greater than 55. The condition is false. It won't execute the swapping statement because it comes inside the block of if, and block of if will be executed when the condition in the if is true. So if the condition is false, so it comes again at the increment decrement part. It increment the value of j. The value of j will become 3 now, right? And then it checks the loop condition, j less than or equal to 4. So 3 less than or equal to 4, condition is true. It comes inside and execute this if statement. The if statement is if A of 1, so value of I is 1 now, is greater than A of 3. So A of 1 is 44 and A of 3 is 33. So 44 is greater than 33. The condition is true. Now we have to swap the value of 1th index and the 3rd index. So when these two values are swapped, the array will look like this. So 33 and 44 comes over there. Rest of the elements are same as before. And then the value of j is incremented. It checks the loop condition, inner loop condition. The condition is 4 less than or equal to 4. Condition is true. Then it executes the if statement. So if statement is A of 1, that is 33, is greater than A of 4, that is 22. So 33 is greater than 22. This condition will be executed and this condition is true. So again it performs the swapping. It swaps the value of the 1th index with the value at 4th index. So these two values are swapped. Now 33 come over there and 22 comes over here, right? So this is the end of the second iteration of the outer loop. Now the value of j become 5 less than or equal to 4. Condition is false. So it comes outside the for loop. Now it comes to the inner outer for loop, और उसमें value I की value को increment करेगा. Now for the next iteration the value of I will become 2. So this is the second iteration. And at the end of first iteration, the first element is arranged. At the end of second iteration, the second element is arranged. Now the value of I is become 2. 2 less than or equal to 4. 2 less than 4. Condition is true. Then j is equal to 2 plus 1, that is 3. So value of j is 3. Now it start comparing. In the if A of 2 is greater than A of 3, so A of 2 is 55 is greater than 44, the condition is true. So it swap the element at second index and third index, and the array will become this, look like this. So 44 comes over here and 55 over here. Then it will compare. Then value of j will be incremented, that it becomes 4. Now the comparison is a of 2, that is 44, is greater than a of 4. A of j is actually 4. So a of 4 is 33 and a of 2 is 44. So 44 is greater than 33, condition is true, and it will swap the element at second index and the fourth index element, and when these two elements are swapped, the array will look like this. Now the value of j becomes 5 and the condition is false. It comes outside the inner for loop and it increments the counter of the outer loop, and the counter is, and the value of I become 3. Now at the end, this is the third iteration of the outer loop. So at the end of third iteration, the third element in the array is sorted. So वो sort हो चुका element, ठीक है? Now the value of I is 3. It comes, the value of I is 3, check the condition, 3 less than or equal to 4, condition is true, come inside the for loop, j is equal to 3 plus 1, that is 4. So value of j is 4, 4 less than or equal to 4, condition is true. It will compare the element at the third index and the element at the fourth index, that is, it compares the 55 with 44, 55 is greater than 44, condition is true, and it has to perform the swapping, that is, it interchanged the value at the third index and the value at fourth index. So when interchange these values, the array will look like this. So this is the end of the program. Value of j is incremented, it becomes 5, condition becomes false, it comes outside the loop and increment the outer loop counter. The outer loop counter will become 4, 4 less than 4, condition is false, it comes outside the for loop. Now the array is sorted. Let's go and see the program. Now this is the program. So let's make it further complicated. So our array is look like this. So this arrangement is called descending order arrangement, where the larger value is at the first position and the smallest value is at the last position. Okay. So this is the sorting program, and this is the where we are printing the array. So यहाँ पर हम array को print कर रहे हैं, ठीक है? Let's compile and execute. So the input is array is 55, 44, 33, 22, 11, and we are printing the value starting with 0th index goes to the 4th index, and the array is 11, 22, 33, 44, and 55. Okay. Now let's see that what is the result of the each iteration of the outer loop. So let me write over here. So let's make another variable. So यहाँ पर हमें पता चल जाएगा कि फर्स्ट आइट्रेशन के बाद, सो इनर लूप की एक दफ़ा एग्जीक्यूशन के बाद अरे की पोजीशन क्या है, दैट इज़ द रिजल्ट ऑफ द first iteration or second iteration or third iteration and fourth iteration, and then the final result, right? Print f. So this is the final result, and final result is the result of the fourth iteration. ठीक है, जो last iteration का result है, that is the final result. After execution, %d /n I plus 1. So let's declare that variable k is another variable. Okay, because it is inside this loop, and I is the loop counter for the outer loop, so if I use it over here, then it will change the value of I and the program won't work correctly. Okay, let's compile it, execute it. Okay, let's make So after execution 1, this is the result. The first element is at its position. After execution 2, you see the second element is at its position, and after execution 3, the third element is at position, and after execution 4, fourth execution of the outer loop, or the fourth iteration. So the fourth element is at its position. This is the iteration number 1, 2, 3, 4, and जब ये चारों elements अपनी position पर आ जाएंगे तो fifth element automatically comes at its position, and this is the final result. That is the result of the fourth iteration, right? Now let's see the other sorting technique, that is a bubble sort. So in bubble sort, we have again the iterations. We start comparing the 0th index element with the 1th index element, and if the 1th index element is smaller, we will swap that value. So this value is swapped, then compare the value of 1th index with the next index. So here you bubble up the largest element and take it to the end of the array. ठीक है, आप largest element को pick करते हैं और उसको end पे ले जाते हैं. So if 44 is larger, it comes over here, and in the next comparison 44 and 55 will be compared. Since 55 is larger, so it won't swap these value, and then it compares 55 with 22, right? And the 55 is larger, so it swap these two values. 55 comes down, and it compares 55 with 11. 55 is larger, so 55 again comes down, and it comes over here. So you see, after the execution of first iteration of the outer loop in the bubble sort, the largest element comes at the end of the array. Okay? In the second iteration, it start comparing the 0th index value with the 1, and then if the element at 0th index is larger, it swap these two values, and then 1 with second. Now this element is larger than the element at the second index, so it swap these two values, and the value become 22 and 44. Now it compares 44 with 11. So 11 is smaller, so it takes that element to that position, second index, and at the third index the value 44 will be copied. So in those values को swap कर देगा. That is, at the end of second iteration, this is the output, and here you can see the second largest element comes at the second last position in that array. Now start comparing 0th index with the 1th index. Yes, this element is larger, it comes down. Then it compares that larger element with the second index element. Then again this 1th index element is larger, it comes again down. So at the end of this iteration, you see the 33 is at the third largest element is the third last position. Then it compares the 0th element with the 1th element, with the 1th index element, and the 0th index element is larger than the 1th index element. Then it swap these two elements, and the 22 value at the 0th index element comes at the 1th index element. So at the end of the fourth iteration, the fourth element comes at its position, and when these four element comes at their position, the fifth element is the first element, that is the smallest element, and that is already in its position. So the largest element comes at the bottom after the execution of first iteration, and the second largest element comes at the second last position after the second iteration, and after the third iteration, the third largest element comes at the third last place, and after the execution of fourth iteration, the fourth largest element comes at the fourth last position in the array. So this is how bubble sort works. Now let's see the insertion sort. So insertion sort mein you start comparing 1th index element with the 0th index, and if this value is greater, you swap these two values. So since this value is already smaller, so you won't swap this value, and then you start with the second index, you compare it with the first index value. Here you can see that this value is smaller, so we are arranging in the ascending order, where the smaller values goes up and the largest value goes down. So 33 is smaller than 44, So 33 will be swapped. Here we perform the swapping. So 33 will be go at the 0th index position and 44 will come at the 1st index position. That is like this. In the second iteration, अब यहाँ पर इन्होंने iteration को complete करके नहीं दिखाया हुआ, right? So in the second iteration, the second index element is compared with the 0th index element. ठीक है? And if that element is smaller, if the a of 2 is smaller than a of 0, then you have to perform swapping, and here there is no need to perform swapping because a of 2 is greater than a of 1. Then you start comparing with a of 2 with a of 1, and a of 1 is also smaller, then there is no swapping in the iteration 2. Then in third iteration, you take the next element and start comparing it. Then this is 22 at the third iteration. Now the 22 is smaller than 33, so you have to perform swapping then. So 33 comes down over here and 22 goes over there, right? And then 33 that comes over here, that will be compared with the 44. Then again this 33 is smaller than 44, so 44 comes down and 33 goes up. Okay? And then 44 will be compared with this value 55, and the value is smaller, so 44 goes up and 55 goes down. So after the execution of third iteration, this will be the array. So 22, 33, 44 and 55. Now you compare 11, the last index element, 4th index, with the 0th index. So 11 is smaller, it goes up, 22 goes down. Okay? And then you start comparing this value, whatever value is here, that is 22, that you compare it with 33 then. So 33 is larger, so 33 goes down, 23 goes up. Then the value is 33. 33 will be compared with 44, and then 44 is larger, so this value goes down, right? And 33 goes up over here. So 44 is over here, 55 is here, then 44 is compared with 55, value 55 is larger, then this value goes down and 44 goes up. So the output will be look like this: 11, 22, 33, 44 and 55. I haven't write or showed you the program for the bubble sort and the insertion sort, so I assume that this is your homework. Take it as your homework and write the program for the bubble sort and insertion sort and check whether they work or not. Then we comes to the topic where we are passing an array to a function. In the previous lecture, I have shown you that how we can pass individual element of the array to a function, where we are passing the individual element by value and by address to that function. We have seen these two things, but when we are talking about the array, passing an array to a function, in this we are only allowed to pass the address of array to a function. So here pass by value is not applicable. So C doesn't provide the provision to pass an array by value. You can just pass an array to a function by address. That is the only mechanism, only way, right? So here you can see we have an array num whose size is 6. So there are 6 elements in the array, and we are calling the display function and passing it the address of the first element of that array. So first, the address of the first element of that array, that is also called the base address of the array or the starting address of that array. So when this statement is executed, this memory will be allocated to the 6th element of the array, and let's assume the addresses are 500, 504, 8, 12, 16 and 20. Now you know why there's a gap of 4 between the addresses. Okay. The next statement is the function call. So when this function is called, this statement will be executed and the memory will be allocated for this pointer j. So pointer j के लिए memory allocate हो जाएगी, and then which value will be passed to this function, that is the address of num0. So num0 that is the 0th index element. What is the address of this element? That is 500. So 500 will be passed to this pointer. So the value contained by the pointer, that is the memory address, it is 500. Now this pointer points to this memory location. right? Now we have a variable I. So execution of the loop, you initialize the variable I with 0, check the condition, I 0 less than or equal to 5, condition is true. Then then there's the output, that is this printf statement. So it print element A is equal to %d, and in place of %d you are printing the value of static j. Now what is static j? Static j is static 500. And how we can read static 500? We read it value at address 500. So what is the value at address 500? That is 24. So this is the output, element is equal to 24. Next, you are incrementing the value of j. So value of j increment ho rahi hai. Since j is a pointer, it's not an ordinary variable. So how much increment will we perform? The increment of 4 byte will be performed, 4 values will be performed, because when you increment a pointer, it means that it has to point to the next value of the same type. Same type mean जिस type का pointer है उस type की value को point करेगा. So ये integer type का pointer है. So पहली एक integer value को point कर रहा था. So next integer value 4 bytes away होगी from the current position. So the value of this pointer becomes 504 and it points to the next element of that array. Then counter of the loop, that is I, is incremented, it becomes 1. We check the condition, 1 less than or equal to 5, this condition is true. Then we have again the printf statement, element is equal to %d. Again we are printing the value of static j, but this time j is 504, so the value at address 504, that is 34, this will be printed. Then j will be incremented, j will become 508. Now the value of I is incremented, I become 2, 2 less than or equal to 5, the condition is true. So when this condition is true, it executes the printf statement. Now this time it says value at address 508. Now that value is 12, that will be printed. J will be incremented, its value becomes 512. It points to the 4th element of the array whose index is 3 and address is 512. So value of I is incremented. Condition of the loop will be check I 3 less than or equal to 5, condition is true. Here you can see the condition is true, and then printf statement will be executed. So the value at address 512, that will be printed on the screen, and then j will be incremented. So j increment jab hoga to value become 516. Then loop counter will be incremented, its value become 4 less than or equal to 5, condition is true. Then in the printf statement you are going to print the value at address 516, that is 56, that value will be printed. Now the value of j is incremented and that becomes 520. The loop counter becomes 5, the condition is 5 less than or equal to 5, condition is true, because we have to execute the loop 6 times starting with 0 till the value of I is 5. So in the printf statement it prints value at address 520, that is value 17 will be printed on the screen, and then j will be incremented. The value of j will become now 524. It points to the next memory location, right? And then the value of I is incremented, it becomes 6. The condition in the loop is I less than or equal to 5, that is 6 less than or equal to 5, condition become false. It comes outside the loop and control will be transferred back to the place where you call this function, and then this system pause statement will be executed. So you see we have a display function. We just pass the base address of the array and it prints all that element, all the value of all the elements in that array. ठीक है, so हमने just उसको base address बताया. This is the base address of the array and it start printing the elements from that address, and in each iteration it also increments the pointer value. Let's go and see the program. So this is the program. We execute this program and now this is the output. The value are 24, 34, 12, 44, 56 and 17. Perfect. So here we have a function, display function, that is used to display the value of any array, right? So for example, if I have another array, integer a, okay, it will determine its size by itself. I just assign the value 103, 114 and 159, and then I call the function and again display and a. So I have a display function now, and I can pass that function any integer array, right, at the base address of any integer array, and that function display that array. 113 and 117. So now it prints the first array and then the second array, right? So we have 6 values, 156 again. So this is the first array, 24, 34, 12, 44, 56, 17, and this is second array, 103, 114, 159, 113, 117 and 156, right? So we have a function, we just pass the base address of that array and it will print that array. But what if we have an array that contains just 3 elements, not the 6 element? हमारे पास एक ऐसी array है, let's say A is an array that contains only 3 elements. That is, will that function be able to print that array? No, the output will not be the correct one, because it will print these 3 values correctly, because the loop is executed 6 times every time you call this function. So this function is perfect to print an array whose size is 6, but not for an array whose size is not equal to 6. So जो बड़ी array होगी या छोटी array होगी, जिसका size 6 से बड़ा है या जिसका size 6 से छोटा है, उस केस में ये problem create करेगा. What problem it should create? If the size is smaller than 6, the loop iterates 6 times. So it will print these 3 values and then the values of the other memory location, and you will be surprised at what it is going to be printed. So let's see, if I double comment this thing, if I comment out this thing, the displaying of this first array, and we just want to display this array whose name is A, element are 3. Now what will happen? Let's see. So you see, it prints 103, 114, 159, 1979, 16, 2379. So this is not the value of the array. I just assigned these 3 values, but it print these 3 values by itself. So what is the wrong with the function? So we have to improve the function. That is, we must pass the second parameter to that function, that is the size. Now A is an array whose size is 3, num is an array whose size is 6. Now this function should work fine, but we have to change the definition as well. We have to have a variable that's a size, and we have to execute the loop size minus 1 times, because size is 6, so loop will be executed 0, 1, 2, 3, 4, 5 times. Okay, so 6 times loop will be executed, and if the size is 3, the loop will be executed 0, 1, 2, so 3 times loop will be executed, right? So we have to change the prototype of the function, integer, second parameter is also integer, first parameter is the memory address. So now if I call this function, let's compile it and execute the program. Now it prints just 3 values, same function, because I am passing the size of the array, and that loop is executed only that number of times, 3 times only. So if I comment this out and uncomment this thing, now this is an array whose size is 6. Now I'm passing the size of that array, and this loop will be executed 6 times now, starting from 0 to 5, right? So let's compile it and execute it. So you see, 6 times. Now we can say that we have a display function that is used to display any integer array. You have to tell 2 things to that function: the base address of the array and the size of the array. Size means total number of values or elements in that array, right? So you have to tell this thing to the function. So example functions are display, integer static p, integer size, that we have just seen. The other function you can write is sort ascending. So this is the base address of the array, right, and this is the size of the array. Now you have to do the sorting in the array. So आपने function को base address बता दिया. Now the function can access the original value of that array because it knows the address, and you also tell the size of that array. So sort underscore ascending function will make that array whose base address is the first parameter in ascending order. Similarly, we have a function that will organize the elements of the array in descending order, and the address of the array is in the first parameter, the base address, and the size is the second parameter. So I hope you should be able to write these three functions by yourself now, and consider it as your homework. Write these functions, and if you find any difficulty, you can write me an email at my address that I have shown you in my first lecture. Write the program that you have written and write the problem, and then write me the email. I will definitely reply your email. Then array and pointer. So that is the real thing, we can say, real food for thinkers. So this is an array num whose name is num, and the size of the array is 6 because we are initializing num array with 6 values at declare time, so there is no need to specify the size. This is optional. So in such situation where you are initializing an array at declare time, the size of the array becomes optional thing. So whether if you want to mention it or if you won't want to mention it, it's up to you. But if you have to mention it, you should mention it 1 2 3 4 5 6. So 6 should come over here, right? So this is an array in memory, right? So mentioning the name of the array, we get its base address. Like that is, if we write num, then that is the address of the first element of that array. जहाँ से array शुरू हो रही है, किस element से शुरू हो रही है? First element से शुरू हो रही है. So that address is the base address of that array. So we can say and num of 0. That address is the base address of the array num, and that can also be referred as num. So num is actually equal to num and num of 0. Let me repeat it. So num is actually equal to and num square bracket 0 and closing square bracket. So the base address, we can write it and num of 0, we can write it just num. So that is the base address. By saying static num, we would be able to refer to the 0th element of the array. So static means value at address. Num is 500, so we can read it value at address 500. So that value is 24. So static num is equal to num square bracket 0. Num square brackets 0, num, and within square brackets you have a subscript that is 0, so that will give you value 24, and that is same as static num. So that right now I'm not saying and num of 0, I'm saying num of 0. Num of 0 means num square bracket, within the square bracket we have 0, right? That is static 500, that gives 24. So static num and static num plus 0 both refers to 24. Clear? So they both are the same thing. This is a pointer, you are adding 0 to that pointer, that means its value is 500. So the value at 500, that is 24, and the value at 500 is 24 as well. Now static num plus 1 refer to the first element of that array. So let me go back. So static num plus 1. So num is 500. So you cannot change the value of num. So when you say num plus 1, so here you are not changing the value of num. It's not num plus plus, that is num is equal to num plus 1. It is num plus 1. So num plus 1 means that you are not going to change the value of num. So when you add 1 in 500, it means that it becomes 504. So, and static, we have a static with it, static within the bracket num plus 1. So static 504 is value at address 504, that is the value of the first index, that is 34. So static num plus 1 refer the first element of that array. 0th element, first element, or we can say the element at the first index. This means that all the following notations are same. So if we write num of I, we are accessing the ith element of that array, and if we write static num plus I, we are again accessing the value of ith index of that element, and if we again write static I plus num, these are the same things. Let's go and see the program. So this is the same program where we have a display function. Okay, so if I comment this out, because we are not using now the display function, and let me write printf %d %d/n. So I have to copy this thing because I'm going to print that array. So we are going to print the num array. So the loop start from 0 and it goes till 5. It executes 6 times. And now we can write num of I, comma, static num plus I, comma, static I plus num. So ये तीनों सेम वैल्यूज प्रिंट करेंगे. So हर रो में सेम वैल्यू प्रिंट होगी. So this means that if you write num of I, num within square bracket I, and if you write static num plus I, and if you write static I plus num, they are the same. So let's compile this program first. Oops, we get an error. I undeclare. So we have to declare I over here. But we have already declared I over here. Then why it is giving this error? Now this declaration is within display function. This has nothing to do with the main function. But now we are using I within the main function. So we have to declare I within this function. So this is the declaration of I variable. Now there's no error. Let's execute this program. You see, we are getting same values, or like this. So 24, 24, 24. So both these three refers to the same element, right? Okay, let me write the memory addresses as well. So first we print the memory addresses and then these values. Printf %d, comma, %d/n. So this is %d, comma. Now the memory address is and num of I. That is what we already know. Now you can write the memory address as num plus I. Okay, so these both are the same memory address. Because when you put static with this, you are accessing the value at that address. So when you write and num of I, like num of I, then this means that value at index I, right? So let's first compile this program, okay, and run it. Now you can see these are the both same addresses, and the value of this address is this. Both same addresses, both same, and same. And these are the values. Now you know the two methods to access the address of that particular element and the value at that element. We have these three methods. Now you can see that array is actually the pointer to the group of element having the same data type. So array is actually a pointer to a group of element having same data type, but you are not able to change that value, that pointer value. So you cannot write num is equal to and I. So let's see if we write like this. So it gives us error, incompatible type in assignment, because num is an array pointer, right? So it won't allow you to do this. So if I write, let's say 500, then what happens? incompatible type. So the compiler won't allow you to change the value of this pointer, because this is now constant. It points to the group of elements. You can change these values, but it is not allowed to change this pointer value, right? Okay, let's summarize our today's lecture. In today's lecture, I have shown you a pointer arithmetic program, and then we have seen some sorting techniques: bubble sort, selection sort, insertion sort, and we have dry run the selection sort technique. इसमें हमने program देखा, उसको dry run किया, and we execute the actual program of selection sort. And bubble sort और insertion sort को हमने just उसकी execution देखी है, उसका method देखा है, how this execution or sorting will be performed using the bubble sort or insertion sort technique, and I keep it to you to write these programs for the bubble sort and insertion sort. And then we have seen how we can pass the entire array to a function, and here we have seen that we cannot pass the entire array to a function by value. We can just only pass an entire array to a function by address. So, and that is also the efficient way. So just imagine that if you have an array of 100 elements in main function and you are passing that array to a display function by value, then display function also must have an array of 100 elements, and each element will be copied to that position. So that will also take time and it will consume memory. Rather than this, you just pass the base address of the array to the display function, and then in display function it occupies only 4 bytes for a pointer that contains the address, and that pointer points to the array in the main function. And then we have seen the array and pointer concept, and in this we have seen that array is actually a pointer, and the name of the array is actually a pointer to a memory location that has a group of element having same data type. That's it for the today. Thank you for listening.